So if we look at 4.2, the unit circle, okay, remember our unit circle is based off of x squared plus y squared equals 1. Where the center of my circle is where? 0, 0, your origin. And my radius is what? 1, right? My radius is 1. Now, from that, we can split this circle into different parts where we can make into like 45, 45 triangles, 30, 60, 90 triangles, all of that, right? Okay. Now, our trig functions as our sine, cosine, tangent, cosecant, secant, and cotangent, right? Okay. Sine, again, is just labeled SIN. Do you guys remember what cosecant is labeled? Nope. CECSC. Cosine is COS. Secant is SEC. Tangent, TAN, and cotangent, COT. Okay, so just know all of those. I put them underneath because they kind of go with each other. They're inverses of each other, right? Okay. All right. Now, the definitions of our trig functions based off of the unit function. Okay, so when we divide our circle into different parts, like pi radians, pi over 6, 2 pi over 6, things like that, which is pi over 3, we can actually get coordinates around our points using our special right triangles. Do you guys remember the rules for special right triangles? The 45, 45, 90, the 30, 60, 90 triangles. Okay. And look at this. 45, 45. If we have a 45, 45, 90 triangle, what do we know about the legs of my right triangle? Huh? I can't hear you anyway. They're equal, right? So if I make these both 1s, what is my hypotenuse? You want to know what the hypotenuse would be? Square root of, close, 2. Why? Because 1 squared plus 1 squared would equal my hypotenuse squared, right? So 1 plus 1 is 2. The square root of 2 is just the square root of 2. Okay. Does anyone remember our 30, 60, 90? And obviously my triangles look the exact same, but that's okay. Let's do my short side is always across from the 30. I'm going to say that's 1. Does anyone know what the hypotenuse is? 2. Yep. And then what is my longer side? Root 3. So you're close. Yeah, root 3. Okay. So when we actually divide our unit circle into parts, that's where when you look at the coordinates, they're coming from if it's a 30, 60, 90 triangle or if it's a 45, 45, 90 triangle. Okay. Now, from these trig functions, if I want the sine of whatever radian we're at, okay, so it could be pi over 6, it is always equal to y. And y is my y coordinate of that point. Okay. Cosine of t, which is again my radian, is equal to the x coordinate. Tangent is the y coordinate divided by the x coordinate. The cosecant, okay, is, remember, like the inverse or the reciprocal of the sine. So it's just 1 over the y coordinate. Secant is 1 over the x coordinate. And the cotangent is we take the reciprocal, which would be x over y. And again, x can't equal 0 in the tangent, and y can't equal 0 in the cotangent. Why? Because you can't have a 0 in the denominator. Exactly. Okay. All right. So if we look at the unit circle, if we divide our unit circle into 8 equal parts, okay? At 8 equal parts, the first degree radian is 0, okay? And 0 will correspond with the point of 1, 0. That should make sense to you guys, right? If we don't go 0 degrees or 0 radians around my circle, I'm going to stay on that x-axis, right? And so we would correlate with 1, 0. Okay. Now, if I divide it into 8 equal parts, my first one would be 45 degrees, right? And what is 45 degrees in radians? Pi over, oh, pi over 4, right? Pi over 4. Okay, and pi over 4 radians is going to correspond with radical 2 over 2, comma, radical 2 over 2. Okay, and again, that comes from our 45, 45, 90 triangle because we're going up 45 degrees. Okay. If I go up to 90 degrees, that would be what radians? Pi over 2, and that corresponds with the 0.01. Okay. Over another 45 degrees, which would be what radians? So 90 plus 45 is 135. So what would that be in radians? 3 pi over, no, 4. Okay, that's 4. That corresponds with negative radical 2 over 2, comma, radical 2. Okay. Then if we go all the way to 180 degrees, no, pi. All right, go another 45 degrees, which is what, 200 and something? Where would that put me? Huh? 5 pi over 4, yep. If you guys notice, this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, then 5 pi over 4. Then the next one would be 6 pi over 4, which is 3 pi over 2. And as you can see what coordinates correspond. Then what? 6 pi over 4, so 7 pi over 4, which corresponds again with that coordinate. And then all the way around the circle gets me to 2 pi. Okay. All right, now if we divide this into 16 parts, every part we're going up how many degrees? 30 degrees, right? Because we're splitting half the circle in 8 parts and then the other half in 8 parts, right? So when we look at that again, 0 radians is still going to correspond with the 0.10. All right, now I'm going to go up 30 degrees, which would be pi over what? 6. Would be pi over 6, right? And that corresponds, because we're going 30 degrees, it's corresponding with that 30, 60, 90 triangle. That's where we get the coordinate of radical 3 over 2, comma 1/2. Okay. I know it's hard for you guys to see on your screen. Hopefully you can see it on your paper better. Okay. Now, if I go another 30 degrees, that would be a whole 60 degrees, right? Technically. So that would be pi over 3, okay, which corresponds to 1/2 radical 3 over 2. And then another 30 degrees puts me at actually 90, which is pi over 2. Another 90, or another 30, excuse me, would be 2 pi over 3. 2 pi over 3. Okay. Another 30 would be 5 pi over 6. Another 30 puts me at 180, which is just pi. Oops, I didn't see that. Just pi. All right, and then keep going down. Okay. Keep going. So we would have 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and 2 pi. Okay. Now, do you guys remember how to turn radians to degrees? Or degrees to radians? If I'm taking degrees to radians, I divide by 180, right? And times it by pi. If I'm changing radians to degrees, I multiply by 180 and divide by pi, okay? So that's how we could have also figured out this. If you know you're adding 30 degrees every time, you could have always just divided by 180, right? Yes. Yeah, exactly. Yep. All righty. So now we're going to evaluate the 6 trig functions at each real number. I have 4 examples here. We're not going to do all 4 examples. Okay. We will talk about, we'll do 2 and then we will talk about the other. Okay. All right. So pi over 6. Okay. So the easiest way is saying t equals pi over 6. So my degree or my radian is pi over 6. So I'm going to end up finding the sine of pi over 6. I want to find the cosine of pi over 6, the tangent of pi over 6, the cosecant of pi over 6, the secant of pi over 6, and the cotangent of pi over 6. Okay. Now, the first thing we need to do is what coordinate corresponds with pi over 6? So what coordinate corresponds with pi over 6? So pi over 6 would be 30 degrees, right? And where did that put me on my unit circle? At what coordinate? Yep, radical 3 over 2, comma, 1/2. Okay, is everyone okay with that? Okay. Now, we know from our trig definition of the trig function that the sine of whatever is equal to y. So the sine of pi over 6 is the y coordinate where it corresponds. So what is the y coordinate? 1/2. So the sine of pi over 6 is 1/2. The cosine of pi over 6 is equal to x, right? And what is my x coordinate? Root 3 over 2. So the cosine of pi over 6 is radical 3 over 2. Tangent is always y divided by x. So what is my y coordinate? 1/2 divided by, what's my x coordinate? Radical 3 over 2. Can I leave it like that? No. So this is the same thing as actually taking 1/2 times the reciprocal of radical 3 over 2, right? Which is 2 over radical 3. So what's 1/2 times 2 over radical 3? What happens to these 2's? They cancel. So I'm left with 1 over radical 3. But can I have radical in my denominator? Nope. And so how do I rationalize that? Multiply by radical 3 over radical 3. And what do we get? Radical 3 over 3. Good. So the tangent of pi over 6 is radical 3 over 3. Okay. All right. Cosecant is, remember, just the reciprocal of my sine. So if my sine is y, my cosecant would be 1 over y. So 1 divided by, what is my y coordinate? 1/2. And what's 1 divided by 1/2? Isn't that the same thing as 1 times 2 over 1, which is just 2. Secant is the reciprocal of cosine. So this is going to be 1 over x. So it's going to be 1 over, what was my x? Radical 3 over 2. So we can't have that. So it's going to be 1 times 2 over radical 3. Now, can I have radical in the denominator? Nope. So we multiply by radical 3 over radical 3. So we get 2 radical 3 over 3. There you go. Okay. And then the cotangent is the reciprocal of the tangent. And the tangent was y over x. So what's the reciprocal? X over y. So my x is radical 3 over 2 divided by y, which is 1/2. So we have radical 3 over 2 times 2 over 1. And what do we get? Just radical 3. Okay. There you go. Okay. Does that make sense to you guys? Okay. Now, pi over 4. We're not going to do this one, but what is the coordinate that corresponds with 5 pi over 4? What is the coordinate that corresponds with 5 pi over 4? Negative root 2 over 2, comma, negative root 2 over 2. Good. All right, what about pi? Negative 1 comma 0. And what about negative pi over 3? Negative pi over 3. What do you guys think with negative pi over 3? Okay. So let's look at our circle. Okay. So if we're using regular pi over 3, are we looking at dividing it from 8 equal parts or 16 equal parts? 16, right? So we know pi over 3 goes up by 30 degrees, right? But we want negative. So which direction will I go? Down. So it's going down here. So that corresponds with radical 3 over 2, comma, negative 1/2. Yep. What do we say? Radical 3 over 2, comma, negative 1/2. There we go. Now, would we be able to apply everything we just did with those 2 coordinates? Yes. Is there any one on B or D that you want to do? No. Okay. Now, one thing, if you look at this one in B, our y is 0. So is there any trig function that will be undefined? Yeah, which ones would be undefined in this case? Okay. Cotangent of pi is going to be undefined because remember, cotangent is x over y. So negative 1 over 0. Can we have 0 in my denominator? Nope. So that's why this one is undefined. Okay. What other one would be undefined? Cosecant. Cosecant is 1 over y. So 1 over 0, again, is undefined. Okay. Now, would we be able to calculate everything else from that? Probably have a lot of zeros or negative 1s, right? Okay. All right. Any questions so far? Are we good to keep going? All right. Domain and period of a sine and cosine. Does anyone know the domain of a sine or cosine function? Do we remember what a sine curve looks like? There you go. Yeah, right? So if we have a sine curve, goes through the origin, right? But it's like this. Keeps going. Do you remember that? Where we have the amplitudes, the periods, all of that. So what would be the domain of a sine curve? What do you think? Yeah, negative infinity to positive infinity. Yep. Now we can put it into a certain period, maybe from 0 to 2 pi. So that would change our domain, right? If I want to say my domain is between 0 and 2 pi. But as a whole, our sine curve is always negative infinity to positive infinity. What is my cosine curve? It starts at the top, right? And then goes down like that. Okay. Something like that. Again, negative infinity to positive unless we put in a certain window of it from 2 pi to 4 pi or 0 to 2 pi, something like that. Okay. The range is from negative 1 to 1. Okay. Or negative 1 is less than or equal to sine of t, which is less than or equal to 1. And we know, guys, what's the sine of t equal? Y. That's why those are the exact same, right? Same thing for x, because the cosine of t is just the x coordinate of that value, okay? All right, the periodic is the functions that behave in a repetition, right? Repetitive manner. So every single time we have the same curve going up and down from that, right? Definition of a periodic function, okay? The function f is periodic when it exists positive real number c such that f of t plus c would equal f of t, okay? The reason why this works, think of this. If we go around the circle one time and then add like pi over 3, isn't that going to still be the same thing as just pi over 3? Yeah. So what this means is if I bless you, I have f of 2 pi plus pi over 3, isn't that equal to the same thing as f of 7 pi over 3? Are those equal to each other? Well, let's think about this. If I'm starting at 1, 0 here, right? If I go 2 pi over, that takes me around the circle once, right? Yes. And then we go up to what? Pi over 3, right? So we'd end at pi over 3. Okay. What's 7 pi over 3 actually equal? Isn't that 2 pi plus pi over 3? Okay. Because isn't that the same thing as 2 and 1/3 pi? So when I go around the circle to 2 pi and then up pi over 3. Now, let me ask you, is that going to equal the same thing as just pi over 3? Right. Because if I go around, again, around, all the way around up to pi over 3, isn't that the same thing if I just would have gone up to pi over 3 and not go around the entire circle? Yeah. So if they ask you to evaluate 7 pi over 3, couldn't we just find whatever pi over 3 is? Yeah. Okay. So that's what that means in that sense. So we're going to evaluate kind of all of this at the same time. Okay. Now, we've learned even and odd trig functions, haven't we? Or not, just even and odd functions. Yes, it was on your final, right? If it's even, remember, we plug in negative x and we get back to the original problem, right? When it was odd, you plugged in negative x and you got what? The exact opposite. So everything had to change signs, okay? So when we look at sine and secant functions are always even. So the cosine of negative t is also going to equal the cosine of positive t. The secant of negative t is also going to equal the secant of positive t. So if I say the cosine of t equals 5, what would be the cosine of negative t equal? 5. Because it's even, they're always going to be the same. Okay? Sine, cosecant, tangent, cotangent, they are odd. So they will always be the opposite of each other. Okay? So if I say the tangent of t equals 5, what would tangent of negative t be? Negative 5. They're always the opposite of each other. Okay? All right. All right, so let's look at use the period of the sine function to evaluate the sine of 13 pi over 6. Okay, so what this means is we want to find the easiest way to find 13 pi over 6, because our unit circle doesn't go to 13 pi over 6, does it? No, it goes to 2 pi at the max, right? So 13 pi over 6 is the same thing as adding what to function? Huh? 2 pi plus pi over 6, right? Aren't those the same thing? Yeah. So we can say that the sine of 13 pi over 6 is equal to the sine of 2 pi plus pi over 6, right? Which is also going to be equal to just the sine of what? Pi over 6. And now, can you guys find what the sine of pi over 6 is? Yeah. Remember, the sine of pi over 6 is equal to the y coordinate of that point. And what was the y coordinate of that point? We've already done this one, actually. What was the y coordinate of this point? Is it just 1/2? Yeah, it's just 1/2. There you go. All right. Now, looking at B, use the period of the cosine function to evaluate the cosine of negative 7 pi over 3. So now we're going backwards in this sense, right? Okay. So what I'm going to do is we want to find, because our unit circle is based off of positive, right? Actually, I'm going to change this to 7 pi over 2, if you guys are okay. That's what I meant to have. Okay, 7 pi over 2. Okay, negative 7 pi over 2. Okay, so we want to look at it in a positive sense, right? So in this case, if I just look at 2 pi and add to a negative 7 pi over 2, or to get to it, right? If I just start at a 2 pi, 2 pi plus what would get me to a negative 7 pi over 2? Would that give me a positive value here? If I add 2 pi to something, would I ever get to a negative 7 pi over 2? We could, but it wouldn't make. Now, what if I made this negative? Would that help out a little bit? Could I go backwards negative 2 pi? Yeah. Well, if I look at negative 2 pi, which is, let's put it in terms of 4. So if I had negative 4 pi over 2, plus what would get me to that negative 7 pi over 2? Is this value going to be positive or negative still? It's still going to be negative, right? That would be negative what? 3 pi over 2. So that doesn't really help us because we're still in that negative sense. A little bit easier because we could look at where negative 3 pi over 2 is, right? But let's go. What if I go around the circle 2 times? Where would that put me? Negative 4 pi, right? So negative 4 pi is the same thing as negative 8 pi over 2. Negative 8 pi over 2 plus what would get me to that negative 7 pi over 2? Pi over 2. Is that one positive? Isn't looking at it as a positive form a little bit easier than a negative form? Yeah. So we can actually say now the cosine of negative 7 pi over 2 is actually the same thing as the cosine of negative 4 pi plus what? Pi over 2, which is equal to just the cosine of pi over 2. Now, would you be able to find the cosine of pi over 2? Yeah, we know the cosine is always x. And what's the x coordinate of pi over 2? 0. 0. Okay. So I always think, try to turn it into a positive fraction that we add to, okay? Because that way we can look at our unit circle to move it around a little bit easier in that sense, okay? Now, we could have used negative 3 pi over 2, right? Because those are, we know over 2 going backwards would put me at that y-axis above the origin, right? So we could have done it in that sense, okay? All right, let's look at the last one. Evaluate the sine of t given that the sine of negative t is negative 4/5. Okay, so real quick, is the sine even or odd? It is odd. So we know if they're odd, the functions are going to be what? They're going to be opposite. So if the negative t is negative 4/5, the sine of t has to be a positive 4/5. I don't know why I put plus or minus. It's supposed to be there. A positive 4/5. And there you go. Right. Now we get to use our calculators. Okay. Using a calculator, evaluate each. And let's go ahead and round to the thousands. Make sure, guys, especially on your quiz next Wednesday, you round correctly, because if you don't round correctly, we'll mark you wrong. Okay. I'm actually ahead of the game. I got your quizzes, guys, written up for next week. Now, as you look at these, are these in degrees or radians? Radians. They will never tell you radians. They will only put the degree symbol, okay? That's how you will know the difference between degrees and radians. Radians, they won't have anything. Degrees, they'll actually have the degree symbol up there, okay? So for you, you're going to hit sine 2 pi divided by 3 and your parenthesis. Always, always, always use the pi key. Don't use 3.14, please. Every calculator has a pi key. Yes. Huh? Thousands. You're welcome. Thousands. All right. So what do we get for the sine? Everyone has sine on your calculator. What did you guys get? 0.866. Did anyone not get that? Okay, good. Okay, if you didn't, it's because you're in degrees and not radians. Okay. Now, cotangent. If you look at your calculators, do you guys have cotangent? No. Okay. Huh? We got inverse tangent, but the inverse tangent is used to find the degree measures. Okay. We're not doing that, are we? What do we know about the cotangent? It's the reciprocal of, right? The reciprocal. So I'm just going to look at it in this sense. We know tangent is equal to x, right? Cotangent is equal to what? 1 over x, right? Isn't another way to write that x to the negative first power? Is that the same? Because remember, if we have x to the negative first power, don't we have to move it to the denominator to make it positive? Yeah. So how we do this? Okay, so I know I just put it in. I'm looking at it in this sense for a second. Yes, it is technically y over x. All right, so y over x. We're going a little bit. So that would be x over y. So that would be y to the negative first over x to the negative first, right? The main idea is I wanted to look at how it's -1 to the exponent. Okay. Thank you, JD. So we're going to use actually the tangent because we have that key. So we're going to take the tangent of 1.5, and then we're just going to raise it to what power? The negative first power. You know how to use the negative first power? You guys have a key that says x to the negative first. You can just hit that at the very end. Make sure you put tangent, the whole tangent in a parentheses though. Okay, not the 1.5. So make sure you have a parenthesis around the entire thing. And we'll do thousandths again. And we get 0.071. Good. Yes. Yes, you could do 1 over tangent too. Yeah, because that's where the negative one. Exactly. That's why I started with 1 over x, but then JD fixed me on, put it y over x. But yeah, you could do 1 divided by tangent too. Or, yeah. Okay. All right, any questions with 4.2? That's everything on that. Okay. All right, let's look at 4.3. In your notes packet, guys, it says 4.1. I typed it wrong. Okay, so make sure you put 4.3 up there. This section comes from your geometry class, not necessarily your trig class. Okay, so a lot of review on that sense to it. You've talked about angles of depression, angles of elevation. We'll talk about our normal trig functions, your special right triangles. The only thing that comes from your trig class is writing your trig identities. proving that the left side equals the right side using these trig identities that you have, okay? Our right triangle here, okay, as long as we have a right triangle, if we label this angle as theta, we know the two angles are gonna be acute angles, won't they? If we have a right angle? Yeah. Now, the side, if this is the angle we're talking about, the side across from it is known as the opposite side. The side across from the right angle is always known as the hypotenuse. And then what's the other side that's next to the angle known as? The adjacent side. Adjacent, I can't even spell right now. I'm just gonna put it adjacent. I know. There we go, adjacent. Okay. Now, when you guys learned this, you probably learned SOHCAHTOA, because that helps you with how do we set up our ratios of each trig function, right? Okay. So if we look at the sine of theta, the sine of theta is always what over what? Opposite over hypotenuse. Cosine is always adjacent over hypotenuse. The tangent is always the opposite over my adjacent. Okay. Now remember, cosecant, secant, and tangent, they're just the reciprocals of sine, cosine, and tangent, right? So if my sine is opposite over hypotenuse, my cosecant is hypotenuse over opposite. Secant is going to be hypotenuse over adjacent. And cotangent is adjacent over hypotenuse. Right. So use the triangle to find the values of my 6 trig functions of theta. Okay. So now, real quick, we need to know the measures of all my side angles or side lengths. We know my leg is 3, my other leg is 4. How would I find my hypotenuse? Or does anyone know it off the top of their head? It'd be 5. Remember, that was one of those special, right lengths. But if we didn't know that, how could I find that 5? Pythagorean theorem. I could have done 3 squared plus 4 squared equals my hypotenuse squared. So 9 plus 16 is 25. And then we take the square root of that. So C is 5. And we didn't have plus or minus because can a side length be a negative value? Okay. Now, what is the sine of theta? So if my theta is here, what's the opposite? 4 over what's my hypotenuse? 5. Cosine of theta is adjacent over hypotenuse. So what's the adjacent side? 3 over what's my hypotenuse? 5. Tangent of theta is my opposite over my adjacent. So that would be 4 over 3. Cosecant of theta is the reciprocal of sine. So that would be 5 over 4. Secant is the reciprocal of cosine. So that would be 5 over 3. And then the cotangent, again, is the reciprocal of tangent, 3 over 4. Now, you just found all the ratios of that. Would anyone know how to find the actual angle measure? The inverse function of your calculator. So you would hit second sine of 4 divided by 5, and that would give us our angle measure. Okay, just so you know that. Okay. Find the values of sine of 45, cosine of 45, and tangent of 45. So we need to know our 45, 45. What did we say our special right triangle? What did we say the legs of a 45, 45, 90 triangle is? They're the same, right? And again, it really doesn't matter what values you use, but I like ones because they're the easiest, right? So if my legs are 1, what would my hypotenuse be? Huh? Root 2, yeah. So now, would we be able to find the sine of 45? Yeah, the sine of 45 would equal, what is my opposite? And it doesn't matter that both my angles are 45. So what's the opposite side going to be? 1 over, what's my hypotenuse? Root 2. But can we have root 2 in the denominator? No. So multiply by radical 2 over radical 2, which is radical 2 over 2. What do you think the cosine of 45 would be? The exact same thing. Why? Because my leg values are the same. And what would be my tangent of 45? 1. Yeah. Guys, do you remember? 45 degrees is what radians? Pi over 4. What coordinate of our unit circle matched with pi over 4? Radical 2 over 2, comma, radical 2 over 2, right? Isn't my sine my y coordinate? Cosine my x coordinate? And if I divide these, don't I get 1? So all of it kind of corresponds, but now we're looking at it as degrees instead of our radians. Okay. Look at our 30, 60, 90s. All right, what's my short side again? 1. What's my long side? Root 3, and my hypotenuse is 2. So my sine of 60 degrees. Okay, so from 60, what's my opposite? Radical 3 over, what's my hypotenuse? 2. I don't need to simplify that, do I? No. Cosine of 60. Cosine of 60 is, adjacent is 1. Adjacent, 1. And the hypotenuse is 2. You go to do sine of 30. Huh? There you go. Oh. And guys, real quick, what does the sine of 60, what is that as in radians? Is it sine 60 degrees? Pi over 3. And doesn't pi over 3, what was that coordinate? 1/2, comma, root 3 over 2. Yeah. All right, sine of 30. Opposite over hypotenuse, so isn't that 1 over 2? Yep. And the cosine of 30 would be radical 3 over 2. And 30 degrees corresponds with pi over 6. Okay.
Where did you get like the numbers for the outside of the triangles for the lengths?
Okay, because we learned back in geometry that our short side or our hypotenuse is always 2 times my short side. And the longer side, which is across from the 60, is the short side times radical 3. So I picked a value for the short side and I picked 1. Okay, because 1 is the easiest number to go through. Okay, so then to get the hypotenuse, I take 2 times it. So 1 times 2 is 2. And then to get the longer side, I take the short side times radical 3, which is 1 times radical 3.
Okay, so then does that just make the adjacent side radical 3?
Yep, exactly. And then if you guys notice, it said equilateral triangle. I didn't draw an equilateral triangle, but an equilateral triangle would have been a 60, 60, 60, and I would have had to draw in the height. I just made the one side bigger for us. Okay. All right. Now, if you look at the next page, I actually wrote out all of these special triangles for you, which was memorization from our unit circle if you really wanted to go through that, right? Okay. But it's all right there for you. Okay. All right, example 4. Use a calculator to evaluate 5 degrees, 40 prime 12, and recall that 1 prime is 1/60th of 1 degree, and 1 double prime is equal to 1/3600 of 1 degree. Okay, we're using a calculator. Can you guys do this? Do you think you can do this? Could you figure out what this is as 1 entire degree first? Okay, and then I forgot a word in here, so we'll have to add to that. But can you guys make that into a degree, a full out degree? Yeah, we should, because we have 5 degrees, so I'm going to take 5. 40 prime is equal to 1/60th of a degree, right? So I'm going to take 1/60th and times it by what? The 40, yep. And then I'm going to take 12 is 1/3600 times 12. And then what would I do to this to get my actual degree? What do you think? I just add them up. Okay. So what is that actually in degrees for me? So I'll let you guys do that real quick. And then I got to add in a word. We get 5.67 degrees, yes. All right. Now I want you to find the secant of that. So we're going to find the secant of 5.67 degrees. Now the secant is always the reciprocal of what? Cosine, yeah. So we can do it 2 ways, as Aiden said. You could take 1 divided by the cosine of 5.67, or couldn't I just take the cosine of 5.67 and then raise it to the negative first power? So you can do it either way in that sense. Okay, and what did you guys get? And we'll round to 1,000s again. 1.005. Why? Why did Nolan get something different than you? What do you think? Probably still in radians. Yep. How many else got like 2 point something? Yeah, it's okay. All right. That's the biggest thing that people do, is you forget to convert back from degrees to radians or radians to degrees. Okay. Trust me, it happens all the time. I did it actually when I was doing the notes the first time. I was like, why can't I get the right answer? I'm like, oh, yeah, that makes sense. So always make sure, and they will tell you the degree symbol there. If there's no degree symbol, then obviously you know it's in radians. Okay. All right. So our trig identities. Okay. We've already talked about some of them. Okay. The first one actually is our reciprocal identities, which is what we've been talking about. And the cosecant of theta is actually equal to what? Aiden, you tell me on this one. What is the cosecant of theta equal? How did you figure out the answer to the last one? How'd you type that in your calculator? You just do 1 over cosine of theta. Yeah, that's why I asked you, because you actually knew it. All right. Oh, sorry. Hold on. This is sine, not cosine. Why is it sine, not cosine? Because cosecant is. I was just looking off the one I just did. Okay. So the sine of theta would equal what? 1 over cosecant, right? They're just reciprocals of each other. So the cosine of theta would equal 1 over the secant of theta. And the secant of theta would actually be 1 over cosine of theta. Okay. Tangent of theta would equal 1 over cotangent. And then cotangent of theta is 1 over tangent of theta. All right, the quotient, okay, the quotient identities. The tangent of theta is equal to, let's think about this. Remember, the cotangent or tangent before we said was equal to y over x, right? What did y actually represent? What was y equal? The y coordinate, and the y coordinate, it was always represented by what trig function? The sine. And what is the x coordinate? Cosine. So tangent is also equal to the sine over the cosine. So what do you think cotangent would be? It'd be cosine over sine. Yeah. This one you tend to use a lot, to be honest. And then our Pythagorean identities. Okay. Sine squared theta plus cosine squared of theta. What do you think that's going to equal? Yeah, it's actually 1. It's actually 1. The sine squared of theta plus the cosine squared of theta is going to equal 1. Okay. 1 plus the tangent theta squared is equal to the secant squared of theta. So let me ask you, would the secant squared of theta minus the tangent squared of theta, would that equal 1? Yeah, because we can rearrange this using our equations, right? Solving equations, okay? And then 1 plus cotangent of theta is going to equal what? What do you think? If 1 plus tangent squared of theta equals secant squared, what do you think 1 plus cotangent squared is going to equal? Cosecant squared. And again, cosecant squared minus cotangent squared is going to equal 1, right? Cosecant squared minus 1 will equal cotangent squared, right? Just rearranging those all are equal to each other, okay? So let's look at this. Let theta be an acute angle such that the sine of theta is 0.6. Find the value of each using the trig identities, okay? We know the sine of theta is 0.6, right? We need to find the cosine of theta. So as you look at all of your trig identities up here, which equation or fraction, okay, has the sine and cosine in the same identity? It's the only one that has both sine and oh, there's a couple, but has the sine and cosine, but that will help us find it. Do we have any in the reciprocal that has both sine and cosine in there? No. In quotient, we have sine and cosine, but that equals tangent. Do we know what tangent equals to be able to find the cosine? No. What about in the Pythagorean identities? Yes, we have that sine squared of theta plus cosine squared of theta would equal 1, right? Well, do we know sine? Yeah, what is my sine? 0.6. Can we square 0.6 because it says sine squared? Plus cosine squared of theta is going to equal 1. Well, what is 0.6 squared? 0.36. How do I move 0.36 to the other side? Subtract it. And we get what? 0.64. And then how do we get rid of a square? Square root it, yeah. So the cosine of theta is going to be what? 0.8. Did we just find cosine? Yeah. Hey, guys, let me think of something. What is 0.6 as a fraction? 0.66/10, which is 3/5, right? And what do we know about sine? Isn't sine the opposite over the hypotenuse, right? So if I have this, and I know this is 3 and this is 5, what is my other leg? 4. Isn't the cosine 4/5, 0.8? Yeah, so you see how that works? Okay. Now, without using that triangle, because you can find the tangent, let's use what we know. We know sine and we know our cosine. What identity would give me the tangent of theta? We know the tangent of theta equals what? Sine of theta over cosine of theta. Well, what's my sine? 0.6. What's my cosine? 0.8. So what's 0.6 divided by 0.8? 0.75. Isn't 3/4 0.75 using our triangle? Yeah. So let theta be an acute angle such as tangent of theta is 1/3. Find the value of each using your trig identities. Okay, so go ahead and do A for me. The cotangent of theta. The cotangent of theta. What do we know about cotangent if we're given the tangent? The cotangent is the same thing as what? 1 over the tangent of theta, right? So what is 1 over, what's the tangent of theta? 1/3. So the cotangent of theta is what? 3. Good. Right. Secant of theta. Okay. We're given tangent, we're given cotangent now, but we need to find secant. Looking at your trig identities, which one has secant and tangent or secant and cotangent? Okay. I have 1 plus tangent squared theta equals secant squared theta. So can we plug this stuff in? Yeah. So we have 1 plus, what's my tangent? 1/3 squared equals secant squared. What is 1/3 squared? 1/9. So we're taking 1 plus 1/9. What is 1 with a common denominator? 9/9. So what's 9/9 plus 1/9? 10/9. Okay. And the reason why I added it that way instead of making it 1 and 1/9 is because how do we get rid of a square? Square root. And can we take the square root of a mixed number? No, it has to be an improper fraction. Okay. So we're going to take the square root. What's the square root of 10? Square root of 10, we can't actually do it. But what is the square root of 9? 3. So the secant of theta is radical 10/3. Any questions with that so far? Okay. All right, use our trig identities to transform the left side of the equation to equal the right side. So we want the sine of theta times the cosine of, or cosecant of theta to equal 1. Okay. So the sine of theta times the cosecant of theta. Well, what do we know about either sine or cosine or cosecant? Can you tell me about either the sine or cosecant? Huh? The reciprocals of each other, right? So if I know I'm going to leave sine of theta, we can also transform cosecant to be what? 1 over sine of theta, right? And what is sine of theta times 1 over sine of theta? Isn't that equal to 1? Because those cancel out. And so did we get the left side to equal the right side? Yeah, you're done. So this is what I would want to see. Okay. All right. So now B, cosecant theta plus cotangent theta, there's 2 thetas, there shouldn't be, times cosecant theta minus cotangent of theta. And we need that to equal 1. That's a lot to do there, right? But if I have a quantity times a quantity, what's the first thing you guys would think to do? Huh? Distribute? Or what's another thing I could do? Foil? Could I foil those? Yeah, let's go ahead and foil these. What's cosecant times cosecant? Cosecant squared, yeah. What is cosecant times a negative cotangent? Cosecant, cotangent, right? What's cotangent times cosecant? Positive. Can I go ahead and put the cosecant first? Yeah, okay. And then what's cotangent times negative cotangent? Negative cotangent squared. Now, after you FOIL, what's the first thing you're supposed to do? Or the next thing? Combine like terms. Do we have like terms here? Yeah. What do you notice about these? They cancel out, right? Because these was technically a difference of 2 squares, right? So we have the cosecant squared theta minus cotangent squared of theta. Now, do we have anything about cosecant squared or cotangent squared in our formulas? Yeah, what do we know? Right. This cosecant is the same thing as what? 1 plus cotangent squared of theta. You guys okay with that? Yeah. Now, if I replace the substituted in, now we have 1 plus cotangent squared of theta minus cotangent squared of theta. Now what? Can we combine like terms? Do we have any like terms? Yeah. What happens to these two? They cancel out. And now do we have 1 equals 1? Yeah. So you just proved the left side equals the right side using those trig functions or those trig identities. Okay. All right. Any questions with any of this so far? No. Yes. Huh? Because the cosecant squared is equal to 1 plus the cotangent squared. Okay. And that is on your trig identities on the other side, which I don't know if you wrote down. Did you write them down? Or were you sleeping at that point? All right. You're having a rough time today. Yeah. All right. And then the last part is just angles of elevation and angles of depression. I only did one example out of these two. It's just setting up your trig identities, what are your trig functions, whether it's you're using sine, cosine, tangent, those kind, okay? So angle of elevation, it represents an angle from a horizontal upward look, right, to an object. So what you're going to do is you're going to be, I'm like standing or sitting here. If I look up to that light, the angle formed from my eye to the light, okay, is an angle of elevation. Okay. Now, if I'm looking down, then that angle that goes downward is the angle of depression, okay? So sometimes they'll give you pictures, sometimes they don't, okay? But main things they'll say elevation, they might say elevation, depression, so you know you're either looking up or you're looking down from that, okay? So a surveyor stands 100 feet from the base of the Washington Monument. So from the base to the person is 115 feet, okay? The surveyor measures the angle of elevation to the top to be 78.3 degrees. So from where he's standing, looking all the way up to the top, that's that angle of 78.3, okay? So here's my monument. Here's my person. So it's a little bigger, okay? That's 115 feet. From me looking up, we have that 78.3 degrees, okay? How tall, and our monument to the ground, isn't that at 90 degrees? Yeah, okay. How tall is the Washington Monument? So there's my X, there's what we're trying to find, okay? So now, looking at this, if we have a right triangle, can't we use one of our trig functions? Yeah, okay. So what trig function would we use? The side across from this is known as my opposite. Is this my hypotenuse or my adjacent? It is my adjacent. So which trig function uses opposite and adjacent? Tangent. So it's the tangent of my angle. What's my angle? 78.3 degrees equals what? What's my opposite? X over my adjacent, which is 115. Now, do we know how to solve this? The easiest way, I always put the trig function over 1, because now don't we just have a proportion? So I'm just taking this tangent and multiplying it by 115, okay? So 115 times the tangent of the 78.3 will equal my X. So how tall is my monument? And we can round to the nearest foot. So the nearest foot. And again, this is in degrees, so we need to make sure our calculators are in degrees, okay? Degrees. And what did you guys get? 555 feet. There you go. Okay. And if you want to look at one for depression, example 9 in your book is, I just didn't want to start another page on this, to be honest. I'll be